Hi, this video will talk about terminology related to the graph of a polynomial. First, we will discuss where it's increasing and decreasing. Then we will talk about extrema, both global and local. Then we'll talk about turning points and finally x-intercepts. So the first thing we're going to talk about is how to determine when a polynomial is increasing or decreasing. And what you're going to do is just think about walking from left to right. So as I go on this function from left to right, I can see that this function, I'm climbing uphill, or in other words, I'm increasing, until I reach this point here. At this point, which in this case is -3, I then start to go downhill. So my first interval is going where I'm increasing, so we'll talk about that first. The first interval where I'm increasing is going to be from the beginning of this function, which in this case is going to be -infinity, to -3. So that's my first interval, -infinity to -3. And now I include the endpoints for whatever reason. All right, and now I'm going to start walking again, but I can see from -3 here to approximately a half. Okay, this function is decreasing. Why? Because I'm walking downhill. So just remember, when you're walking uphill, you're increasing. When you're walking downhill, you're decreasing. So I'm going to go from -3 to, we'll just call that a positive half. All right. Then next, I'm going to be walking from a half, but now I am walking uphill, so I'm increasing till I get to 4. So from, a half to 4, we are increasing. And finally, the last interval, I'm walking downhill, so I'm starting at 4, going to infinity, and I am decreasing. All right, so what you're doing is just when you're going uphill, you're increasing. When you're going downhill, you're decreasing, and you're just reading off the corresponding x values where that's the case. Next, we'll talk about the extrema. We can have a global or overall maximum, a global or overall minimum, and that's going to be the maximum or minimum value of the entire function. So first, let's talk about the maximum. What is the largest value? And again, we talk about these in terms of y. What is the largest value that this function will ever take on? Well, it's right here. Okay. Now I know this function, so I know that that is 24, but you may read that off as 25, and we just write the corresponding y value. So the largest value this function will ever take on is right here, and it's 24. Now let's talk about the smallest value this function ever takes on. It's real tempting to come here and say that, oh, it's -64 or 65. However, that's not the case. Notice that at the end of my function, I have that it is going off. So it's going off to infinity. All right, so the smallest value this will ever take on is -infinity. But since we can never quite get to infinity, either positive or negative, we would say that this does not have a global min, none. So if you're tempted to write positive infinity or negative infinity on the global side, then write none. All right, now let's talk about local max and mins. A local max and min is where if I'm walking around in this area here, okay, I don't have a clue what's going on in this part of my function, but I see that I'll reach the top of a mountain here. So when we talk about local maxes and mins, we're talking about the top, any peaks, okay, or tops of mountains that occur. I see that I have 2 here, or any valleys that occur. They don't have to be the smallest, they don't have to be the largest. It's just any that occur. So I see that I have a local max at 24, okay. I have a local min at, we're going to call that -64, all right. And then I see I have another local max at 24. It's the same as this one, so I don't notice in this case my global max and my local max are the same. That's perfectly okay. And notice that I have a local min at -64 while I have a global min. Next, we're going to talk about turning points. Notice the word point. Whenever we think of points, we think of a coordinate pair. So when we talk about turning points, we're going to give both an x and a y coordinate. A turning point, by definition, is just where I go from increasing to decreasing or decreasing to increasing. Okay, so I have basically a turning point here, increasing, reach the top of the mountain, and I start decreasing. I have a turning point here, okay, and I have a turning point here. Okay, and now, like I just said, we talk about them in terms of both the x and the y. So my first one's going to be minus 324. My next one is to be minus, or I'm sorry, 0.5 and minus 4. And my last one is going to be and 24. Okay, so that's just the coordinate pair associated where I turn, in other words. Finally, we're going to talk about the x-intercepts. The x-intercepts, just as with a quadratic, this function crosses the x-axis. Alright, I see I have one there, I have one there, I have one there, I have one there. So that's all we're talking about when we talk about x-intercepts. So I'm just going to list them. Minus 4, 2, 3, and 5. Okay, and those are just the x value, corresponding x values where this function crosses the x-axis. So I hope that this helps to clarify our terminology and to help you to start thinking about how to interpret